Alright, I want to continue going through some problems that we worked on in class. Remember, pause each one of these, try it out yourself, and then watch how I do it. And some of these I'll do silently if it gets kind of repetitive, but you'll still see the step-by-step, and if you have questions you can ask me in class. So this one is the natural logarithm of x minus the natural logarithm of 2 equals 0. Remember that ln is the same thing as log base e, so we can still look at this as log base e if you want to. We don't really want to get in that habit though. We want to recognize it and still use the properties of logarithms as we go through these, because it is still a logarithm. And one of those properties is if we have a minus sign, the same log with the same base, meaning the same base there, we can say this is the same thing as natural log of x divided by 2 is equal to 0. And then from there we can solve this by taking the inverse of both sides, or you could look at it as log base e of x over 2 equals 0 and rewrite it in exponential form. So if you're rewriting it in exponential form, you say, hey, that's e raised to the power of 0 is equal to the x over 2. X over x, x over 2. And e to the 0 is the same thing as 1, and so we have x is equal to 2. If we take the exponential of both sides, well, it's just saying e raised to this is equal to e raised to this. And so these two are inverses on the left side, so they cancel, and we get x over 2 is equal to e to the 0, which is 1. And so we get x equals 2 there as well. Now it's important that we go back and substitute our answer in to make sure we don't have an extraneous solution. So the natural log of 2 here is what we get, and we don't take the log of a negative or a 0 there. And so I know I'm going to be okay with this. And that should make sense. If I get the natural log of 2 minus the natural log of 2, it's the same number minus the same number, it's going to give me 0. So that checks out as well. So here we're going to use the one-to-one property we talked about in the first video. We've got e as our base, and it's raised to something on both sides. So since we have the same base, we can set those somethings equal to one another. And we're going to subtract x from both sides. And then factor. And so I'm at a point where I know I've got two numbers being multiplied and they give me 0. So one of these numbers or both of them are going to be 0. So either x equals 0 or, let's see, x minus 3 equals 0, which gives you x equals 3. If you put 0 in, you get 1 right there. You put 0 in here, you get 0 squared minus 0, which gives you e to the 0, which also equals 1, so that checks out. If you put 3 in over here, you get 9 minus 6, which is 3. E to the 3 equals e to 3, so that works. So both of these are going to be your solution. Now this one gave some of you trouble in class, so when you get stuck, sometimes just rewriting things in a different manner will make everything else make a little bit more sense. So looking at this one, if I take this 0.2 and write it as a fraction, then I can kind of see where both of these are going to start looking like the same base. Now I know 1/5, recall that if I have x to the negative 3, that sends that x to the denominator. So it's the same thing as x 1 over x cubed. Or if I have x to, or 1 over x to the negative 5, that's the same thing as x to the 5th. And so with the 5 in the bottom, the base is 5 and it has like an exponent of 1. If I move him up top, I can do that and just make the exponent negative 1. So just like how x to the negative 3 is the same thing as 1 over x cubed, 5 to the negative 1 is the same thing as 1 over 5 to the first. And now I have these as the same base. And so with the same base, I can set the exponents equal to one another. So I get t equals 2. So let's see if this works out. If t is equal to 2, then you get 5 to the negative first, which equals 0.2. So that one does work. This is one like we did in the first video. We're going to say, hey, this is 3 squared. This is 3 to the x minus 1. Set the exponents equal to each other. Once again, we want to get these to where they're looking like the same base. When I first see this, I say, hey, that's 8 squared. So no, this is the same thing as 1 over 8 squared. But 4 is not something that I can make 8 raised to. I know that it's the same thing as 2 squared. And I know 8 is the same thing as 2 cubed. So this is like saying 2 cubed squared, all in the denominator, which is the same thing as 1 over 2 to the 6. And if I want to bring this back to the numerator, I need to make that exponent negative. So this is the same thing as 1 over, not 1 over, we want to get rid of that, don't we? It's the same thing as 2 to the negative 6. I need to distribute the 2 here, and so I get 2 to the 2x plus 2 equals 2 to the negative 6. So 2x plus 2 must equal negative 6. And so subtracting 2 from both sides, you get 2x equals negative 8, or x is equal to negative 4. And if you check this, you get, putting in negative 4, it's the same thing as 4 to the negative 3, which is 1 over 4 cubed, which is 1 over 64. And so it will equal that in the end. For this next one here, I know I already got 1/2, so I'm going to look at changing this 8 into base 2. So I know 8 is 2 cubed. And that's raised to the 2 minus x. I don't like having the 2 to the first in the denominator. I'm going to move him up top and make it 2 to the negative 1 raised to the x. And now I'm just going to multiply the exponents. So I get 2 to the negative x equals 2 to the 6 minus 3x. Since the bases are the same, I can set the exponents equal to each other. And you get x equals 3. And if you check this, you get 1/2 cubed, which is the same thing as 1 cubed over 2 cubed, which equals 1 over 8. And on the right, I get 8 to the negative 1, which is 1 over 8. So those balance out. Next one, this one's kind of like the last one. I'm going to move this 3 up top and make it 3 to the negative 1 raised to the x minus 1 equals 3 squared. So you get 3 to the negative x plus 1 equals 3 squared. So x equals negative 1. And 1 minus 1 gives you, just checking here, gives you a negative 2. So it's like saying 1 to the negative 2 over 3 to the negative 2, which is the same thing as 3 squared over 1 squared, which equals 9. And that equals this. Sometimes this confuses students because it's got an e in it, and you're like, what do I do? Natural log, whatever. Remember, this is like saying e to the first, not e to the x. So if I make this so it's not a fraction, it's going to be e to the negative 1 equals e to the x plus 1. Now I get the same base as e. So I can say x plus 1 equals negative 1. And so x here equals, subtract 1, not 0. Whoops. X is going to equal negative 2. And so if you check it, you get over here on the left e to the negative 1, which is equal to 1 over e. Sometimes I go through these too fast and I start making mistakes. Subtract 1. 2x equals negative 2. X equals negative 1. That's why I like to still check. So negative 2 plus 1 is negative 1, and that equals out. So here's where I don't have memorized that 4 to a power equals 256. But if I take 256 and divide it by 4, I can almost bet you it does. We'll see. Look, it does. 4 times 64 gives you, 4 times 64 gives you 256. And I know 4 cubed is 64. So 4 to the 4th must be what this is equal to. And so the right side is the same thing as saying 4 to the negative 4. So x minus 1 equals negative 4, or x equals negative 3. And the next one gets into logarithms. We're going to do that in the next video because I'm already pushing 12 minutes on this. So hopefully that's another set that's helped you out there, and keep working hard.